So this example is an example of a revenue question. So as the question reads, a railway company offers excursions at $120 per person for tour groups of up to 100 persons. If the size is greater than 100, the company will reduce the price by 50 cents for each person. What size group will produce the greatest revenue? Okay, so right away we see the word greatest revenue. So that means we need to come up with an expression for revenue. So revenue is basically the price of whatever it is you're selling or buying multiplied by the quantity of whatever it is that you're selling. Now, the variable that we're changing here is the price. So every time we drop the price by 50 cents, we get an extra person. Or if we have an extra person, they're going to drop the price by 50 cents. So I'm going to let X represent the number of price changes. So when I generate my equation now, and I think about the price, the starting price was $120. And the company is going to reduce the price. So that's a minus 0.5x multiplied by the quantity. So at $120, there's 100 people. Every time the price changes by X, one more person's going to go. So now we want to sort of talk about what our domain is going to be. So X, we have two brackets, so we're going to look at it and see. I want to look at 120 minus 0.5x equals 0. So X is going to equal 240. So if there are 240 price changes, then obviously the company won't be making any money because you'll end up with 0. Now on the other side of things, in terms of the quantity, we have 100 plus X equals 0. So X could also be negative 100. Now you're probably thinking, well, can there be negative price changes? Well, technically there can. Because we're saying in this situation that a price change is a reduction, perhaps they might do an analysis and find that the increase in price is actually a better situation. So our domain is X is an element of the reals such that we have negative 100 is less than X, which is less than 240. Okay, so before I do my derivative, I'm going to expand it. So we have 12,000 plus 120x minus 50x minus 0.5x squared. So now I'm going to do my derivative. So r prime of x, the 12,000 goes away. The derivative of 120x, should have actually probably simplified that first, but because I've already started, I'm going to have 120 minus 50 minus x. So I'm going to have 0 equals 70 minus x. So x is equal to 70. So now I go back and I look at the question, and the question is, what size group will produce the greatest revenue? So I just found that x has a value of 70, so my number of people, people, will be 100 plus 70 to produce the greatest revenue is 170. You could have been asked to calculate the value of the greatest revenue. Or you could be asked, what is the price that optimizes the revenue? So there's a bunch of different ways that you can use the value 70 to come up with some different answers. Okay, all right, our next example. So it's similar to one we've done before. So we have an open top storage box with a square base. So I'm just going to do a quick little sketch of a prism. And I know that my sides on the bottom, or my base, has the same dimension, and I'm going to call this h. So I know that volume is x squared h, and in this example I have 5 because that's the number that's given to me. Material for the sides costs $1.60 per meter squared, while that for the bottom costs $2 per meter squared. Find the dimensions that will minimize the cost. And then what is the minimum? So minimize the cost. We're not being asked to minimize the surface area here, which is what we did in the other example, but we're being asked to minimize the cost. So we need to come up with an equation for the cost. So I know that the cost is going to equal $1.60 times the area of the sides plus, I don't have enough room there, $2 times the area of the base. So I'm going to have 1.6. I have 4 sides and they're all xh because of the square base. And I have plus $2 times x squared, and I'm not including the top. So then this ends up giving me 6.4xh plus 2x squared. So the same problem we always have. I have 2 variables. So the easiest variable to isolate for is the h. So that will give me 5 over x squared. So now I'm going to have 6.4 multiplied by x multiplied by 5 over x squared. Plus 2x squared. So I'm going to clean that up. So that's going to be 32 over x plus 2x squared. Now, when we think about our domain, I'm looking at getting a volume of 5. So I know that x can be between 0 and 5. That's not quite true when we're looking at it, but I know that x for now is going to be greater than 0. All right, so I have my cost. So I'm going to take the derivative of the cost with respect to x. So this is going to become minus 32 over x squared plus 4x. I'm going to sub in 0. I'm going to get a common denominator. So I have negative 32 over x squared plus 4x cubed over x squared. So I'm going to multiply everything by x squared, so I get 0 equals negative 32 plus 4x cubed. So 32 equals 4x cubed. 8 is equal to x cubed. 2 is equal to x. So I found my dimension of x to be 2. So now I'm going to scroll all the way back up and see what question is being asked. So I believe it wants to know the dimensions that will minimize the cost, and it wants to know what the minimal cost is. So right now I have x equals 2. So h is going to equal 5 over 4, and I should put some units in here. I believe that they are in meters. And then I need to calculate the cost. So I'm going to use 32 over 2 plus 2 multiplied by 2 squared. So 32 divided by 2 is 16 plus 8. 16 and 8 is $24. So that's how we do a question where we incorporate the cost. The mistake students make here is they just do the surface area equation, take the derivative, and solve for that. However, you're not minimizing the surface area, you're minimizing the cost.